In this video I'm going to explain the Vieta's theorem. Here x1 and x2 are the roots of the equation ax squared plus bx plus c, which is quadratic equation here, is equal to 0 of course. And when you get the x1 and x2, if you remember, x1 was equal to minus b plus root of delta over 2a, and x2 is equal to minus b minus root of delta over 2a it was. And x1 plus x2, so if you want to find the x1 plus x2, it was equal to minus b plus root of delta over 2a, and plus minus b minus root of delta over 2a it's going to be, which is equal to minus b plus root delta minus b minus root delta over 2a it's going to be. And here if you simplify this 2, it's going to be equal to x1 plus x2 is going to be equal to minus b and minus b, it's equal to minus 2b over 2a. It's going to be, if you simplify the 2's, the answer is going to be equal to minus b over a. So I got the terms here, minus b over a, and it's by using the same way, x1 and x2, when we multiply, we are going to get the value c over a. And we are going to find the sum and products of the roots without calculating them, because if you know the equation ax squared plus bx plus c, you can easily get minus b over a and c over a. Minus b over a is the sum, c over a is the product of the roots. It's going to be, here is the question: find the sum and product of the roots of the given equations without solving the equation. We don't need to solve the equation, we don't need to find the x1 and x2. Here we are going to find only x1 plus x2 what it is, and x1 times x2 what it is, because it says that find the sum and product. So x1 and x2 is equal to x1 plus x2 is equal to minus b over a. Here in the equation we need to define the a, b, c. You remember, this is a, this is b, and this is c. So b is equal to 6, and minus b it's going to be equal to, b is equal to plus 6 minus b it's going to be equal to minus 6 over 2, which is equal to minus 3. And x1 times x2, it's going to be equal to c over a, which is equal to, c is here 5 over 2, and we cannot simplify the numbers, so x1 plus x2 it's going to be equal to minus 3, which is the sum. x1 times x2, which is the product of the roots, is equal to 5 over 2 going to be. Okay, if we solve the other question here, x1 squared minus 3x minus 5 is equal to 0. X squared minus 3x minus 5 is equal to 0. So here a is equal to 1, b is equal to minus 3, and c is equal to minus 5 it's going to be. And x1 plus x2 is equal to minus b over a, which is equal to minus 3 over 1, then it's equal to 3, and x1 times x2 is equal to c over a, which is equal to minus 5 over 1, that's equal to minus 5 going to be. Here on this page we are going to find the sum, product, and this values, and this values depends to sum and product, that's why it's the derivation of the at this part we are going to find the sum and product, and the second question is related with the first one, and it says that 1 over x1 plus 1 over x2, and we can derive this to values, and we can get the x1 and x2 in our equation. That's why these are related with the first question. So I'm going to solve only the first question. Second and the third one, it's going to be classwork for us. In the class we will solve these questions. Okay, let me start with x squared plus 3x minus 5. It's obvious that x1 plus x2 for the first one, 1a, x1 plus x2, which is equal to minus b over a, and here it's equal to minus b is 3, minus b is Actually b is 3, b is 3, b is 3, and minus b over a, it's going to be equal to minus 3 over 1, which is equal to, because a is equal to 1 here, and it's equal to minus 3, and x1 times x2, x1 times x2 is going to be equal to c over a, which is equal to minus 5 over 1, and that's equal to also, that's equal to minus 5. Then I'm going to continue with the second one. I'm going to find what is 1 over x1 plus 1 over x2. And I'm going to derive this equation with 2a, let's say, 1 over x1 plus 1 over x2, what it is with respect to this given information. It's equal to, here x2 and x1, they are different denominators. That's why we are going to crossly multiply the denominators, and it's going to be x2 over x1 times x2 plus x1 times 1, it's going to be equal to x1, then x1 times x2, it's going to be, now the denominators are same, we can easily get the common denominator like x1 plus, or let me write the first, x2 is given, x2 plus x1 over common denominator is written only once, which is equal to x1 times x2. So here in this question 2a, 1 over x1 plus 1 over x2, when we derive this equation, we are getting x2 plus x1 over x1 times x2, which is equal to x1 plus x2 is equal to minus 3, x1 plus x2 is equal to minus 3, and x1 plus x1 times x2 is equal to minus 5, then the answer is equal to minus 3 over 5 it's going to be, because both of them is negative, so the answer is 3 over 5 going to be. Here I'm going to continue with the b1. Actually for the b1, x1 square plus x2 square, for the a square plus b square I need here a square plus b square formula. We don't have any specific formula for this one, but we are going to we are getting conclusion here. We can use x1 plus a plus b square minus 2ab, it can be, or I can write with x and y. X square plus y square is equal to x plus y parenthesis square minus 2xy, it's going to be. When you open this one, you are going to get x square plus y square. So x1 plus x1 square plus x2 square with respect to this one, x1 plus x2 square minus 2 times x1 times x2, it's going to be, and x1 square plus x2 square is equal to x1 plus x2 is equal to minus 3 square minus 2 times x1 times x2 is equal to minus 5. x1 square plus x2 square is equal to minus 3 square is equal to 9, minus 2 times minus 5 is equal to 10, and x1 square plus x2 square we are going to get, it's equal to 19. And the last one is the c, x1 cube plus x2 cube. The c1 also I'm going to use x cube plus y cube formula for this one, y cube formula, this one, x cube plus y cube is equal to x plus y times x square minus xy plus y square, it must be. So x1 cube plus x2 cube is going to be equal to x1 plus x2 times x1 squared minus x1 times x2 plus x2 squared, it's going to be. Here the important part is x1 squared minus x1 times x2 plus x2 squared can be separated like x1 plus x2 times, not separated, so it can be written as x1 squared plus x2 squared minus x1 times x2. Now I'm ready to substitute the values. x1 plus x2 I found here, it's equal to minus 3 times x1 squared plus x2 squared. I derived this one and I got 19 minus, and x1 times x2 we know that it's equal to minus 5 minus minus 5 is going to be, so it's equal to minus 3 times 24, which is equal to, because minus 5 it's going to be equal to plus 5, 19 plus 5 it's going to be equal to 24, minus 3 times 24 it's equal to minus 72 it's going to be, so x1 cube plus x2 cube it's going to be equal to minus 72. Here we finished the question, but you need to remember this one. These two, they are formulas, so you need to know, if you want to solve this question, you need to know these formulas from the previous chapters. Okay. Now here we have different type of question. This time the roots are not given, and the b value is also not given, but there is a relation between the roots, and we are going to try to find the value of m. Here it says, you know that one by using the Vieta formula, x1 plus x2 is equal to minus b over a, and x1 times x2 is equal to c over a it's going to be. Here c over a is closer to me, because c over a actually it is given, and x1 times x2 also. Here you may find x2 in terms of x1, because x1 is equal to 3x2, so it's going to be like this. If I derive the second one, x1 is equal to 3x2, so 3 times x2 times x2 is going to be equal to c over a. C is equal to, and c is equal to 1, and a is equal to 3, so it's equal to 1 over 3 it's going to be. x2 squared, it's going to be, if you send the 3 to the other side, it's going to be division, so 1 over 3 times 3, which is equal to 1 over 9, and x2 squared is equal to 1 over 9. If you want to find x2, it's going to be equal to plus and minus 1 over root 9, which is equal to minus plus root 1 over root 9. That's equal to 1 over 3, plus and minus 1 over 3. We cannot take the minus 1. x2 is equal to minus, it cannot be negative, so it's equal to plus 1 over 3, because it's written here non-negative, so x2 must be greater than 0. That's why this value, negative 1, we are not going to take, and the value of the x2, it's going to be 1 over 3. So x1 is equal to, here it's going to be equal to 3 times x2, which is equal to 3 times 1 over 3. The result is going to be equal to 1. So x1 is equal to, it's going to be equal to 1. And the last one, they are asking for m, and we are going to find the m by using the x1 plus x2 formula. x1 plus x2 is equal to minus b over a, which is equal to 1 plus 1 over 3 is equal to minus 2 over 3, minus 2m over 3, I'm sorry. And here it's equal to 3 times 1 plus 1, it's equal to 4. 4 over 3 is equal to minus 2m over 3. It's going to be 3 and 3 is same on the both sides, and they are both denominator, that's why you may simplify. Then 4 is equal to minus 2m, and m is equal to 4 over minus 2, which is equal to minus 2 going to be.